Welcome back, class, to what is going to be the last video of this week, where we just talk a little bit more about areas between curves. So I have given us here two graphs, the graph of 2x and the graph of x squared minus 2x plus 3. And we want to find the shaded area. So what's weird about this question? What do we have to look out for? And so remember, our formula for the area was that the area is given by this integral from a to b of the big function minus the small function. That is, the function that's above minus the function that's below. Okay. What happens in this case is that which function is above and which function is below actually changes. So what that means is I'm actually going to have to find this area in two pieces. So let me kind of reproduce the graph just very roughly here. So I have this piece, and then something that comes down and then back up like that. So I've got this piece here and this piece here. And so for this piece, it's the parabola g that's the big function and the line that's the little function. Whereas for this piece over here, I should point at an actual part of the region, it's the line that's the big function and g of x that is the little function. Also, unhelpfully, I have no points labeled, so I need to figure out what the points are. So to figure out what the points are, I need to set these two things equal to each other. So we'll set x squared minus 2x plus 3 equal to 2x. Subtract the 2x over, we'll get x squared minus 4x plus 3 equals 0. We'll factor this. This will give us x minus 3 times x minus 1 equals 0. So that'll give me x equals 1, x equals 3. Okay, so this point here, that must be 1. This point over here, that must be 3. Okay, so that means I'm going to need to find this area and this area separately. This is intended to be a B. I'm going to redraw it. B. So area A is going to be the integral from 0 to 1 of x squared minus 2x plus 3 minus 2x dx. Okay, this is our area formula again, because here for A, I'm going to hide this graph now so that you can see it. So here for A, the graph that's the big graph is the parabola, so that's g, minus, and then the graph that's the small graph is the line, so that's f. So I write down that minus that. Whereas for B, it's the other way around. So I integrate from 1 to 3 of, and now it's 2x minus x squared minus 2x plus 3 dx. Okay, so I need to calculate both of these integrals and then add the answers together, and that will give me the total shaded region in the picture. Okay, so let's look at A first. So A is the integral from 0 to 1 of x squared minus 4x plus 3 dx, which is, this is going to be x cubed over 3 minus 2x squared plus 3x, evaluated as x goes from 0 to 1. And so when x is 1, this is 1/3 minus 2 plus 3. And when x is 0, this whole thing is just 0. And so that means the first area here, area A, it's 4/3. Okay, when I go to look at area B, copying down our formula from before. Area B is now the integral from 1 to 3 of minus x squared plus 4x minus 3 dx. Okay, and you'll notice I just swapped these around. So this thing I'm integrating in B is exactly the negative of the thing I integrated in A. So this is equal to minus x cubed over 3 plus 2x squared minus 3x, evaluated as x goes from 1 to x equals 3. Again, note you get exactly the negative of the antiderivative that we used for A, because, again, B is exactly the negative of A. Anyway, once we have that, we can go ahead and plug in 3. So this is minus 3 cubed over 3 plus 2 times 9 minus 9. And then minus, and don't forget to plug in x equals 1, minus a third plus 2 minus 3. Okay, so this is minus 9 plus 18 minus 9 plus a third minus 2 plus 3. Okay, and so this whole piece is just 0 because minus 2 nines and plus an 18. And so this is also 4/3. And so then my final answer is to take the area of B and the area of A and add them together. So I'll get 4/3 plus 4/3, which is 8/3. Okay, so if your area is broken up into pieces, that really means you're going to need to do an integral for each piece using this same formula. Okay, one more example. Okay, in this next example here, I'm going to use different graph. So I'm going to use this graph. Okay. And I'm going to tell you the curved graph is f of x equals the square root of 36 minus 4x. And my question is, what is the shaded area? Okay, so I'm only telling you one of the graphs, but the other graph conveniently is a line. So we're going to be able to use what we know about graphs to find the equation of that line and then work through this question. So let me attempt again to reproduce approximately the picture so that I can have my full work area here. Okay, so here's approximately the graph. Okay, so I need to know what this point is and what this point is so that I can go about finding the equation of the line. Okay, this is the y-intercept of f. So if you've been wondering this whole semester/year why we did all of these questions of the form figure out these points from the graph, this is one of those areas where that's going to come up. Okay, so this is the y-intercept. So at 0, comma, the value of f at 0. And f of 0 here is the square root of 36, which is 6. So this is 0, comma 6. This point down here is the x-intercept. So I know it is something, comma 0. I just have to figure out what makes the square root of 36 minus 4x equal to 0. So I'll square both sides. So I'll get 36 minus 4x equals 0, which will give me 4x equals 36, which will give me x equals 9. So this point is 0, 6. This point is 9, 0. So if I find the slope of the line, I'll be almost done. So the slope of the line is 6 minus 0 divided by 0 minus 9, which is minus 2/3. And so that means the equation of my line here is given by y equals minus 2/3 x, that's the slope, and I know the y-intercept is at 6, so it's y equals minus 2/3 x plus 6. That's the equation of the line. Okay, and now also given that I know that this is at 9, 0, I know now that the area is the integral from 0 to 9 of the square root of 36 minus 4x minus 2/3 x plus 6 dx. Okay, so let's simplify this a smidge. So this is the integral from 0 to 9 of the square root of 36 minus 4x plus 2/3 x minus 6 dx. And I really want to do this in two pieces. So I want to break this integral up, and I want to think about the integral corresponding to this piece and the integral corresponding to this piece separately. And why is that? The reason for that is because this is going to require a u-substitution, and this one isn't. So I'm going to rewrite this like this. Plus the integral from 0 to 9 of 2/3 x minus 6 dx. Okay, and I'm going to call this here integral 1, so I'll call it I sub 1, and I'll call this here I sub 2. Okay, and at the end of the day, I'm going to have to add those two together in order to get the total area of this region. Okay, so let's do these two. I'm going to do integral 2 first, because integral 2 is the easier one. Save the worst for last. So integral 2 was the integral from 0 to 9 of 2/3 x minus 6 dx, which is 2/3 x squared over 2. So those 2's cancel. Minus 6x, evaluated as x goes from 0 to 9. Which, if you like, that's just x squared over 3 minus 6x as x goes from 0 to 9, which is 81 over 3 minus, and so 6 times 9 sounds like 54. And so that's 27 minus 54. And so this integral is negative 27. Okay, now I'm going to pause for a second here, because if you're paying attention to what everything means, which I encourage you to do, you might think something has gone wrong because this integral has turned out to be negative, and we're talking here about an area. But this is supposed to be negative, because what's really happening here, if you trace back what's going on, what you'll see here is this first integral is the integral from 0 to 9 of the square root of 36 minus 4x. That's the area of this whole region. And so when I go to add something to that to get just the area of this wedge piece, I need to actually add the area of this triangle, but negated. So I really need to subtract the area of this triangle. And so actually, if you look back at what we just did, we actually just did a really complicated and messy algebra mess in order to show that the area of this triangle is actually 27, and then I negate it. But actually, this triangle is 6 high by 9 wide, so the area of this triangle is 1/2 the base times the height, and so it is 27. And so this minus 27 is just that 27 over there. So we tricked ourselves into doing more work than we had to. Anyway, it doesn't matter. You're allowed to do more work. But let's go ahead now and find I1. So I1 here is the integral from 0 to 9 of the square root of 36 minus 4x dx. This is going to require a u-substitution. You might ask, how do I know it's going to require a u-substitution? The way I know it's going to require a u-substitution is that here I have a square root with a function inside of it. So exactly what u-substitution lives to do is break up integrals where we have a function inside of another function. Okay, so I'm going to let u here be this 36 minus 4x. So then du is minus 4 dx. Let me rewrite this a little bit. Let's see, I'm going to need this minus 4. And I'm going to pay for this minus 4 with a minus 1/4 out front. Okay, now I can translate everything. So this is minus 1/4 times the integral of the square root of u du. And so x equals 0. That's going to go ahead and get translated to 36 is u. And this x equals 9, it's going to go ahead and get translated to u is 0. So this is now minus 1/4 the integral from u equals 36 to u equals 0 of the square root of u du. Okay. Now, in the last video, we did an example like this, but what actually happened there is that this u-substitution turned my integral upside down. So I'm going to get rid of this minus sign and turn it back right side up so that the lower limit is actually lower than the upper limit. So this is 1/4 the integral from 0 to 36 of the square root of u du. And then I'll go ahead and evaluate this. So this is 1/4 times u to the 3/2 divided by 3/2, evaluated as x goes from 0 to 36. Okay, so we'll go on to an unprecedented third sheet of paper for this question. And so we do that. This is now going to become a 2/3. So this is 1/4 times 2/3 times u to the 3/2 evaluated as, sorry, I made a mistake back here. I wrote x equals, but I really meant u equals. So you can already see why I really should have written a u equals over here. I already miswrote that, but it doesn't matter. So this 2 cancels with that, becomes a 2. So this is getting a little messy, but we can continue onward here. This is 1/6 u to the 3/2 evaluated as u goes from 0 to u equals 36. Okay, so this is 1/6 of 36 to the 3/2 power. minus, but then it's 0 to the 3 halves power, so that's not going to do anything. 36 to the 3 halves power. Remember, when I have the 3 halves power, that means take the square root and then cube it. So the square root of 6 is then, or sorry, the square root of 36 is 6, and then I cube it, so I get 6 cubed. So this is 1/6 times 6 cubed, which is 36. So we find that this first integral I1 is equal to 36, and then we remember that we set this all up so that the answer was just the sum of I1 and I2, and I2 was negative 27. So our answer here is 36 plus minus 27, which, as it happens, is 9. And that is the area of this shaded region that we started with. And notice if in the middle there you were concerned about, oh no, maybe it's going to work out to be negative, and that would be bad because this is an area and areas are always positive, we ended up in the right place. We ended up with this answer 9 being positive. Okay, so we're going to wrap up there for this week. At the end of this week, I will post the last test, test 5. Then next week, we're going to talk about optimization, which, in addition to an opportunity to review optimization, is also going to be an opportunity to review derivatives, because there's going to be a lot of derivatives on the final. And then that's going to be the last week. So after that, once you get through everything, then you can email me and we can talk about the final and how you'll take that and how you'll email me the answer, and then you'll be done for the semester. So the end is in sight. Hold in there. But until next time, be well.